First, we're going to look at some examples where we just need to find the least common denominator of two rational expressions. And we're going to look at a scenario where you have a monomial, and we'll also look at the scenario where you have, binomials and trinomials. And so there are three main steps to finding the least common denominator. And the first step is generally to factor all denominators and write in exponential form. When you have monomials like we do down here, you don't have to actually factor them because you can see the factors right in front. You can take the numerical coefficients and factor them down into their prime factorization if you want. And then the next thing we're going to do is express the different factors as a product, and then we'll use the highest exponent on each one. And so let's look at this first one, example 2a. We've got two denominators. We've got 8x squared, y to the fourth, and z. And we've got 3xy to the fifth, z. The first thing we want to do is just find the LCD of 8 and 3. And so a lot of you may just know that by looking at it, but you can take 8 and rewrite it as 2 cubed. So you basically have factored 8 and written it in an exponential form. And so step 2 says to express all the different factors as a product. So we know we have, if I want to find the LCD, we have a factor of 2 and we have a factor of 3, right? Breaking those down into their prime factorizations. We see a factor of x, a factor of y, and we have a factor of z. Those are all the unique and different factors that you see in either denominator. And then what we want to do is put the highest exponent on each. And so the highest exponent we see on a 2 is just 2 cubed. The highest exponent we see on a 3 is just 3 to the 1. When you're looking at the x's, you've got an x to the 1, over here. We have an x squared over here. So x squared, right, 2 is the highest power that you see on x. Now we compare the y's, so y to the fourth, y to the fifth. The highest exponent we see is 5. So that's going to be the exponent on y. And then we have z to the 1 and z to the 1, and so the z just remains as is. We only use a higher power, other than 1, if the factor is used more than once in a given denominator. So when we simplify this, we're going to get 8x squared y to the fifth z. Let's look at the next one here. We've got, we don't have monomials, we've got a binomial and a trinomial. And so before you find your LCD, you want to factor the denominators if possible. So we're going to factor the x squared minus 4x plus 3. So that's going to factor as x minus 3 times x minus 1. And so our job when we're finding the LCD, remember we're comparing two denominators. So over here I have a factor of x minus 3. Here I have a factor of x minus 1 and x minus 3. So I write just the different factors that appear. So the only factors that I see are x minus 3 and x minus 1. And then you just ask yourself, are any of these written to a power higher than 1? And none of them are used repeatedly in a given denominator. So this is your LCD. All right, let's come down here and look at another one. All right, our job is going to be to factor each of those denominators, list the different factors that appear as a product, and then if any of the factors are used to a higher power than 1, you want to use that power. So again, if you want to try this one by hitting the pause button and trying it on your own, and then hitting the start button to see the solution, you can do that. Or again, if you don't feel confident enough to try one on your own, you can just watch the video and take notes. All right, so I'm going to factor the denominator to the left. I'm going to take out a 3x, and I'm left with x plus 5. I'm just going to put a little line down the middle so I don't confuse the two. The denominator over here is a perfect squared trinomial, and that is x plus 5 squared when you factor it. So now my job for my LCD is going to be just to list the different factors that appear. So I have a 3, that's the only numerical factor. I have an x, so x is a factor just by itself. And then I have a binomial factor of x plus 5. Now the highest power I see on the 3 is just 1. The highest power on the factor of x is just 1. But x plus 5 is raised to the first power here on the left fraction, but it's raised to the second power in the right fraction. So we're going to give that a power of 2, and this is our LCD. Now, we need the LCD in order to add fractions that have different denominators. And so this is what we're going to do in part 3 down here. Okay, in this section, we're going to be adding rational expressions that have different denominators. So our job is going to be to find the LCD and then to build each fraction so that it has the LCD. We'll add our numerators while keeping our denominators the same, and then we'll simplify our final answer. So I'm going to start here by looking at the denominators of the fraction in 3a. So my LCD, there's only one numerical factor, and that's 5. And then the only other different factors that appear in either denominator are x and y. So the 5 is just raised to the first power. The other way of looking at this is if you have a 5 and the coefficient of 1, the LCD is going to be 5. Right. The highest power that we see on x is a 3. The highest power on y is a 2. So my LCD is 5x cubed y squared. Now what I need to do, and when I rewrite these, I'm going to leave a little space because I've got to build. So just like when you're adding numerical fractions, you've got to multiply the numerator and the denominator by the missing factor. So when I look at the denominator in the first fraction, it's 5xy squared, but my LCD is 5x cubed y squared. And so we're going to ask ourselves, what are we missing here that we need to have? And I need an x cubed, I have an x, so I'm missing a factor of x squared. And so I've got to multiply the numerator and the denominator by x squared. Now I'm going to do that with the second fraction here. I look at the denominator and I ask myself, well, what am I missing that the LCD has? Well, the LCD has a 5, and I don't have a 5, so I need to multiply at least by 5 over 5. It has an x cubed, and I have an x cubed already here, so I don't need to do anything there. The LCD has a y squared, and we only have a y, so we need to multiply by y over y. All right, so we build by multiplying. So we're going to take 12x squared over 5x cubed y squared plus 5y over 5x cubed y squared. And so now we're back to the first examples where we're adding two fractions that have like denominators. So we'll just add the numerators. These are not like, so I have to leave them as two separate terms. And we keep the denominator the same. Okay, in the next video we'll pick up where we left off, and we'll start with example 3b.